So it is my great pleasure to have Peter van Hardenberg with us. Peter was, well, I can't even begin to recite all these accomplishments, but he was one of the founders of Heroku. He is the director of Incandescence Switch, which is a private research lab that does fascinating work in a variety of areas, trying to make computing, I guess, more usable and friendly and attractive for the rest of us. And part of this is local first software, which we'll be talking about, but many other things, very interesting things around UI and so forth. Peter has also done some really interesting other things that we won't get to hear about, like Arctic exploration and Shakespeare and I don't know what else, but obviously he's a very interesting person, but we won't get to find that out. He'll just tell us one aspect, which is this interesting work on local first software and its implications and connection to the network, which is something where F5 might be in a position to do something. So I'm not going to spend more time on intros. I'll let Peter take it from here.
Well, thanks so much for that very kind introduction, Gilad. I should note I was not one of the Heroku founders. I was an early employee. I started the data team, so I built all our database services, but there was already a company when I got there. So yeah, thanks for having me though. My name's Peter, as Gilad said. I'm from Incandescence Switch. We're an industrial research lab, and our mandate is to support creative computing and to use it to augment human intelligence. We kind of reach back to the Licklider Engelbart tradition of computers as empowering tools, because we feel like that's not necessarily how things have been going lately. We could use a little more work put behind that. What do I mean when I say we're an industrial research lab? I mean that we explore design and technical concepts. We build narrowly focused prototypes and we write essays, and we spend about 5 years working on this local first concept now to give kind of a sense of the investment we've made. We do have other research interests and user programming, stylus-based computing, lots of other malleable software kinds of things. But I want to talk about local first software today for all of you, and then connect it maybe to how the network specifically today is causing us problems, the internet is causing us problems, because I hope that might be of interest to you. I should note that some of our work is industrialized, has been commercialized. You can see Muse app, which is one of our first spinouts. That's a media canvas used as a tool for thought on iPad. It's trying to turn the iPad into a personally productive tool for thought, as opposed to just a thing that sits in your drawer unless you want to watch Netflix in the bath. And one of the other technologies that we have industrialized is AutoMerge. It's a CRDT that we've been building in partnership with Martin Kleppmann at the University of Cambridge. So, okay, what is local first software? I want to start by basically claiming that local first software is an answer to the cloud era, which we are in, and its excesses. As Gilad found out this morning, your computer without a network connection is basically like a sort of nice, magnesium brick. We live in an era of spinners and content loading from somewhere else. And, it's pretty much routine. Like if you go to Have I Been Pwned, you don't have to wonder. Yes, of course you have. Your data has been leaked, compromised, stolen, in every imaginable way. It doesn't matter who you are, what you do. I'm positive that you're out there. And on top of that, not only is our software like unavailable, slow, and insecure, it is routinely murdered by the people who operate it. There's an entire blog of products that have been killed by Google. If we go to this website right now, there's just this amazing grid. You can scroll forever. And there's also this wonderful concept of an incredible journey, which is that blog post people put up when their company gets acquired, explaining how they're going to shut down and what an incredible journey it's been making and now killing off this product that you may have come to love. You don't need the cloud to have this problem particularly. This is the BBC Domesday project from 1996. It was an attempt to clone for the digital era the Domesday book of, what year was that? It was like 1100 or 1400 or something like that. You can still read the Domesday book. I mean, not you or me personally. We wouldn't be allowed in with our grubby hands to turn the pages. But you can't actually still read the BBC Domesday Book from 1996 because none of this technology works anymore. So we live in this kind of digital dark age where, the things that we build, that all of us use, that we write, that we make, that we rely on, they will be lost permanently from the historical record. And when people talk about the dark ages, there's this kind of like, ooh, it must have been really bad kind of vibe. But the term the dark ages comes not from like privation or, plague or tyranny, all of which were happening certainly then and now, but from the fact that this period is lost to us. We don't know what happened very well during the dark ages because few records survive. The era we live in now, the computing era we live in, will not survive. It will not be remembered. It cannot be preserved. To be fair, the Domesday project probably can be preserved. I imagine there's a copy of that Laserdisc uploaded on the Internet Archive or somewhere that you could fetch. And interestingly, this is not the permanent state of affairs. We could go back and download ROMs of the old cartridges of video game consoles or DOS applications. But, if you want Google Reader, too bad. Now, okay, this is all gloom and doom stuff. Obviously, there's some benefit. I'm old. I remember the bad old days. So what have we got in exchange for giving up all these things? Well, we get everything everywhere all the time. And that's pretty good. That's kind of a killer feature for the cloud, right? Like it turns out to be pretty nice to be able to access any document from any computer at any time, as long as you give people access to it. So I'm not really proposing we go back to WordStar, though George Martin, author of the Game of Thrones novels, is apparently still writing, or at least theoretically, the last book of the series on this very computer running this very version of WordStar, because that's what was current when he began writing. And I think, there's an argument that we're going through a transitional phase from like a before digital era to, digital era. And there's some kind of like S-curve transition. But when you look at the amount of time it takes to produce, creative output like this, and this is a particular interest of the lab in terms of tools for thought, our intellectual projects can take decades. And so we need to be very thoughtful about the kinds of tools we adopt and their longevity. And I would argue that today, most of our tools are ill-suited to creative endeavors that may take a long time, because we have absolutely no guarantee that the product will be the same or even exist in several years' time. And that's simply not the case with traditional software. Okay, so I'm going to kind of lay out what we feel after thinking about this for a while, the sort of 7 ideals for this kind of concept of local first software should be, and then we'll talk about how we could do it. So the first is that, we want software that has no spinners. Your work should be at your fingertips. If you live in Ashburn, Virginia today, most software is pretty fast because it's all running in US East 1 and an Equinix data center next door. But if you live in Australia, the internet is like intolerable for you because everything is like a second away on every request. So it's terrible. If we had local first software, we can move the data to the user. We don't want our data to be trapped in a single device. And indeed, the cloud is reasonably good at this. We do want to have access to everything that we do across all our devices. But we want the network to be optional. This is a picture of my kitchen. That spot right there is almost always open, but you can see to the right there, my refrigerator, and it provides enough, the combination of appliances provides enough EM shielding that although that's the only place in the kitchen where there's usually a spot to put my, iPad or laptop with the recipe up, if I need to look anything else up, I have to pick up the laptop and carry it to another room because there's no internet there. We also think that, the killer feature of the cloud has been this seamless collaboration. We don't think anybody should or wants to go back to an era where, you're emailing files around and asking which copy of things people have. And, oh, do you have final? No, I have final. Oh, final. What's the date on that one? But we think that this, one of the killer features of the modern era is this collaborative kind of technology. But again, on the flip side, we think that we should be building software for the long now. Okay, maybe not 10,000 years, but it'd be nice to have software that could last 10 years or 20 years. And that's just not the case with most of what we use. And of course, we think that software should be both secure and private by default. And if you keep the data on your computer, then you're ahead of the game. You don't have GDPR obligations if you don't have the user's data. And all of this adds up together to the notion that ultimately, as a user, you should retain ownership and control over your work and your data, whatever it may be. And indeed, if you stuck with the DOS computer, you decide when you get new versions of software, or if you take them, and you decide where your data goes and what becomes of it. And I think that's something that's really powerful and important for creative endeavors and, in fact, many kinds of work. So just reiterate those there. But I also want to make a separate case that this model for local first software, we think it has a lot of value and utility to people who do serious work on their devices, but we think that it makes a big difference for developers as well. Present era software, so-called cloud software, is enormously expensive to operate because it's an incredibly complicated distributed system that's written in multiple programming languages and difficult to scale. I know this firsthand, having built Heroku's database services and operated 1 million Postgres databases on behalf of other people. But not only that, built the actual, Heroku platform as a service and scaled it. At various times, we were the largest EC2 user in the world. And, let me tell you, as someone who was there in the rocky early days of AWS, just because you had a reserved instance doesn't mean you got it when you went to start it. Sometimes they would call us back and say, like, no, we know you've reserved it, but it's in a truck at the loading bay right now. It'll be online soon. We're working as fast as we can. But this sort of idealized 3-tier architecture of UI, API, and database, it really looks a lot more like this. This is the diagram from the cloud native landscape, which shows just the incredible complexity of building for the cloud. Obviously nobody uses all of these services, but just the fact that there's any kind of need for you to be familiar with even a fraction of this many different products, it's sort of a distressing conclusion. Instead, we think that local first software can have a self-contained architecture. And in fact, we've built a number of prototypes that demonstrate this. And let me tell you, it's pretty amazing to be able to build a thing after so many years of working across Ruby and JavaScript and GraphQL and databases and so on, to be able to just write a single piece of software and then deploy it somewhere and have it communicate with other copies of that software. It's an astonishing quality of life improvement. And not only that, but because the software is self-contained, you have much simpler scaling characteristics. You don't have all of these complexities where you have to suddenly switch from Postgres to Cassandra because you're overflowing your Postgres database. Generally, a lot of the scaling challenges, at least I'll claim anecdotally from my experience building and observing the construction of large-scale software, they come from having too many users' data in one place. Like take Slack, for example. If you, and me and everybody else we know just had the data for our own Slacks, it's not like you need a DevOps team to handle the amount of information people can type into a computer with their fingers. So we basically claim that we want to, rethink our relationship to the cloud. So the sort of present day architecture of our systems is that the cloud is this great energy-giving orb in the sky, and we're just sort of the grateful supplicants receiving the power of the cloud. And instead, what we want to do is kind of convert the role of the cloud to being more of a transport and storage engine, right? The cloud is a warehouse where you keep your data when you close your laptop, when you back it up so that if you drop your phone in the toilet, you don't lose your photos. So in conclusion, the basic thesis of local first software is that the software should reside on the user's device, and it should support collaboration with others, whether those are people or other programs running in other places. Hopefully none of this is too controversial so far. I realize that it's maybe an uncommon perspective to take, but I want to kind of talk a little bit about what's out there with local first software today. This is not like a totally made up thing where it's a pie in the sky kind of vision. In fact, many mobile applications, especially sort of the core things found on your phone, already operate this way. So if you have an iPhone, Apple Notes stores a full copy of your notes in your phone and then synchronizes it, probably via iCloud to some service that they have, and that way you can load it on other devices. Similarly, the video game market, because the size, I suspect the reason why is that the size of the assets are so huge compared to other kinds of software that you really can't just stream them down on demand over the network. So, you download software and then it runs locally. Obviously, Dropbox and folder sync services have this kind of local first attitude, and as do calendar and to-do apps often, because people just expect them to be available offline. But I want to call special attention to the fact that as developers, most of us demand that our software is local first, right? GitHub is really, I think, desperately trying to convince us that they should host all of our development in the cloud. And indeed, there's lots of reasons why setting up development environments is a pain in the neck. But I personally don't want to live in a world where, a single vendor not only provides, my source code hosting, but also my, chooses what IDE and IDEs I have available, where they choose my issue tracker and what I can do there. I like to be able to work from my laptop when I'm offline. Many times I have, downloaded some code to work on a flight or a train, or just like, in the backyard, in a chair. And, you go and you open the laptop and you've got your code checked out and you're ready to work. But then you open up the browser tab where you had the issue and you see it for like one frame and then it disappears and you get that little dinosaur. And it's so upsetting, right? Because you have this, this expectation that you will have agency over your work and it's taken from you in the moment because your browser doesn't retain that data. And so I don't think this is necessary. It doesn't have to be this way. And for most of our development tools, it's not. There are some, there's a class of data synchronization tooling called the CRDT, which we're seeing a lot of investment and progress around. We've been working on one for a number of years, but there's also other CRDTs out there like YJS and Diamond Types and various other folks. And what these do is basically provide a Git-like experience on arbitrary data structures. So you can have real-time collaboration, you can merge offline work, and you can have efficient kind of storage and sync systems to do this kind of thing versus the POSIX sort of like, like bytes in an array model, or the HTTP get put post sort of monolithic race conditioning model. So CRDT basically tags to, sorry, I gave a version of this talk in a CRDT conference recently. So I'll unpack this slightly, but a CRDT basically operates in most cases by recording edits to a data structure. So you could imagine a JSON file, but it's constructed as an event stream. So instead of sort of, sending around just the state of the document, what you do is you record each edit to the document along with a logical clock that allows you to order them against other people's edits. So you can tell what the dependency order looks like. So if you edit and I see it, then my edit, came before yours because you saw it, so we can safely replace mine, or vice versa. But it's a conflict if we both made edits without knowing that the previous person, what the previous state was, or without visibility of each other's work. And so CRDTs are designed to help with that. Git is a easy reference point here. With Git, you can make a branch, and if you go to pull when somebody else has already made changes, you have to rebase yours before you can push back up and clobber their work. Mobile devices for a long time, because they exist in this kind of offline, online, spectrum all the time. They have pretty good offline capabilities, and even the browsers have improved quite a bit lately with PWAs and web workers, and Chrome recently has released a file system access API as well. So, we're on an okay path. And I would say that if you listen to this talk and you get excited and you're like, I want to make some software this way, not every piece of software is a great fit for local first kind of approaches today, but I'd say that if you have a modest amount of data and your users are generally free to read and edit any data that they can get access to, then that's a pretty reasonable place to go. Whereas if you need to intersect your software with like a real-time or external world, so for example, if you're managing contended resources like meeting rooms or a bank account, it's maybe not a great fit. Or if you have complex privacy requirements, you know, I don't know that people have really thought through how to run an HR system as a local first app yet. Yeah, and if you have, you know, a petabyte of data, you probably don't want to download it all on all your clients' computers anyway. But there are lots of problems out there. So there's no off-the-shelf solutions, right? You can't just, you know, do like create local first app from the command line and get something that works. And there's still a lot of difficulty in getting this stuff to work cross-platform. So the iCloud ecosystem doesn't work with the web very well, right? You can, you know, build a PWA, but you know, it might work in Chrome, but it probably won't work in Safari. There's still a lot of tough stuff. And we're going to come back and spend a lot more time talking about networking soon, but peer-to-peer networking, I think, is really important for this kind of stuff because you want to be able to work disconnected from the internet, or at least disconnected from any central service. And it's pretty hard to do that today. And I just sort of in passing want to point out that we call them browsers, not keepers. I think it's like a really fundamental kind of problem. You know, the main platform that people build software on today, aside from mobile applications, is a browser. And it basically just throws most data that it touches away, right? I mentioned they like, you know, that one frame blink where you see the thing that you had open and then suddenly it's replaced by the dinosaur. You know, this is like very common experience. And yeah, we can do a little better with like extra work, but the default behavior of a browser is not to preserve the content that you see. And yeah, I think that's just problematic and quite a shame. So I want to talk a little bit about some of the lessons learned in exploring local first software. And I think this one is maybe going to be of interest to folk here. There are sort of several different kinds of data that are characterized by whether they should be replicated or only stored locally, and whether they should be persistent or ephemeral. And I think these things have really significant impacts for everything about how you work with data. And so sort of the classic, you know, data is the kind of stuff you put in a SQL database or in a JSON file. You have sort of a shared persistent document, right? Like that's the contents of your post in a REST API. You know, and a shared ephemeral state, though, is more like stuff you might carry over a WebSocket today, right? Like cursor positions in a text editor, or presence in a chat app. But there's also lots of local only ephemeral state, like maybe what you've typed into a text input but haven't sent. And then separately, we have local only persistent state, which is you know, things that you never want to really leave your machine, or that don't really need to leave your machine. A good example there is you know, the private keys that identify a single device, for example. The other kind of meta insight I want to make is that if you go back to the old days of software, data was a thing. And so, you know, I could email you a PDF, you can fill it out and then email it back to me. I can email you, you know, a copy of a Word document, and then you can stick it on a floppy drive or print it out. It's yours. And if I email you something, I understand intuitively that your thing is distinct from my thing. I don't have to worry that if I keep working on it, you're going to see those changes. And vice versa, you know, I can't take it from you. You know, you have it now. I've sent you the email. There's no putting the cat back in the bag. On the other hand, the cloud model has really pushed us to this idea of data as a place, right? If I have a Google Doc and I give you a link to it, you know, when you come to that place, then Google decides if you're allowed in or not based on the credentials you provide. You know, you don't have the document. You can visit the document, and I can visit the document. And, you know, the ownership of that can change over time. But this also leads to a lot of like kind of surprising and confusing behavior for users where, you know, it's kind of unclear what the intuition should be. You know, if I work on a document offline, and this has happened to me, you know, I had a Google Doc and then I worked on it on a flight and the plane landed and I came back online and I got a little pop-up that said, your version has diverged too much from the original, discarding local data. And I said, what? What? That's a thing? I lost hours of work on this stupid piece. So anyway, I think for local first documents, what we want is actually something that hybridizes both of these approaches. We want data that feels like a thing that lives really truly in the user's device where they have agency and ownership over it, but vice versa, we still want to have these kinds of real-time collaborations. And this is the great puzzle that we've been working on at the lab. The other thing I want to kind of point out is that like this data as a place model has all of these really interesting security problems that are basically invented by the idea that there's only one authoritative copy of the data and we need to guard it carefully, right? And I think that this is a poor model. Vice versa, if we look at like source control with Git, anyone can check out the repo, but if somebody pushes bad code, you can just roll back, you can ignore their pull request, whatever, right? So we manage source changes through deciding what we pay attention to, not who we give permission to, for the most part. I realize that access to the central repository is significant here, but we still retain history. For a real world analogy, this is the Constitution. I can go and get a copy of the Constitution and I can write on it whatever I want. I can say I'm in charge now, and everyone has to do what I say. But nobody cares, right? Like my editing a copy of the Constitution is not normative, much as I might like it to be. So I think those are kind of high level sort of takes on a world where users have agency at the edge, and where we replicate and synchronize data from client to client, as opposed to trying to manage a single authoritative copy and distribute cached versions of that to individual users. All right, I'm going to check the chat and see if there's any questions right now before I start talking about the network. Yes, great. Do I see WASM playing a core role in local first? This is a really excellent question. Yes, certainly. I think one of the great puzzles of the web today is how it continues to evolve when it's already become so slow and complicated. If you've tried to build high performance applications, I have a background, I've done some game development, you operate at 60 frames a second or your users complain, right? That's 12.5 milliseconds. Actually, lately the iPad runs at 120 hertz, which means you only get, was it 6.5 milliseconds or 100 hertz on the monitor I'm on right now, it's 10 milliseconds. That's not enough time to go to US East and come back, right? If you want results, you also don't have a lot of time to do relayouts of an HTML page. And so I think technologies like WASM and Canvas are creating new ways for developers to build interfaces and experiences that can have much better performance capabilities and much, much deeper kind of interventions into how software is built. But I think it's also kind of problematic because I think, in terms of like accessibility and malleability, the web has been really powerful because of things like GreaseMonkey allowing end users to, modify the experiences they have, and for accessibility tools like screen readers to be able to, parse the content and represent it in different ways. And if you use Canvas, then it's just an opaque blob on the screen. It's a rectangle with paint calls going to it. And if you run WASM, then you have a binary blob that's executing and the user doesn't know what's wrong and they can't really intervene if they do anything. That said, I do think it's going to be a huge transformative technology, and we've been building WASM-backed applications for a while now. Okay, do I qualify apps like Google Docs as local first apps? I absolutely do not qualify a Google Doc as a local first app. I think that Google has tried very hard to add local capabilities, offline support to Google Docs, but you cannot really use Google Docs without a network connection from any device with a modern browser. You can install a browser plugin and then hope to heck that when you turn off the Wi-Fi, it will be working and that you'll have downloaded the data and that it will actually be there. That's like a fundamentally different set of user expectations and experience. So, when I say local first, what I don't mean is local maybe later after the fact if you're lucky and did the right things. What I mean is that if we build our apps around this notion of local first, just like we got to sort of web first or mobile first over the years, then we don't have to ask ourselves later, oh no, did I blow it? Did I forget to download this data? You already had the document open at some point on this machine. It should still be there. Why are we throwing it away, right? So I think a lot of Google's designs are based on previous generation cloud technology like operational transform, which doesn't support disconnected or peer-to-peer use very well. Modern techniques are building up around sort of the CRDT literature, and I think those are going to make it much easier to build truly local first applications. Do I see a resurgence of thick apps or a fundamental change in how browsers behave? Hard to say. I think less about thin or thick or client or server and more about like the potential, one is giving agency back to the users and giving people more capability to work in the ways that they want and in the contexts that work best for them and to have reliable software that can last. I think that there is only one browser left and it's owned by Google, and Microsoft has like, a reskinned version. I guess that's a bit dismissive of Moco and Mofo. Mozilla is still out there doing Firefox, but it's like, not really a strong competitor these days. Let's put it that way. And so Google's business is advertising and surveillance of its users. So I don't really see a huge amount of potential for Google to take these problems very seriously. I know some folk like Alex Russell who have spent years pushing on this, and it's possible that because of competition internally with the Android team that they will continue to invest in these capabilities. But I think it's so hard to make fundamental changes to a software platform used by 6 billion people every day that it's hard for me to imagine the browser like really truly making very substantial changes to its experience or capabilities. But I don't know. It's hard to predict the future. That's the problem with it. I saw somebody unmute and turn on their video to maybe ask a question earlier. So I'll give a moment if anybody else had questions either in the chat or here before we move on. All right, well, let's move on then. I want to talk about the problem with the network. And I think there's no clearer way to illustrate how we've screwed up than with this picture. This is some picture from a cafe of people working. These people's laptops are all on the same desk, but if they want to collaborate on a document, I can pretty much guarantee you that all the packets are going to Ashburn, Virginia, to an Amazon data center called US East 1. All right, maybe not all the way to Ashburn. Maybe they have a local copy in US West, or maybe it's actually a Google product, and so there's something in Mountain View. But regardless, it is obviously deranged on the face of it that in order for computers on the same Wi-Fi network to communicate with each other, they have to go out of that network, potentially around the world, to some remote service and then come back. We've mentioned this earlier. This is a much bigger problem depending on where you live. Many of us have the good fortune to live in or near places that data centers exist, like the Bay Area or the Triangle on the east, or you're up in Seattle. It's very much not the case if you live in Australia, Singapore, South Africa, or places like that. South Africa doesn't even have a node on this little graph I pulled up here. And as we discussed earlier, our laptops don't have a definitive copy of the data. They have to go and get one. So if we want to actually have peers communicating with each other and to have those laptops on the same machine talking, most of the time, I'm at my house, most of you are at your houses. And so what we would do is, since we ran out of IPv4 addresses and nobody bothered to get IPv6, working, I'm skipping over a lot of controversy there. Let's just say IPv6 is not as widely deployed as some people might prefer. But so we need to solve this NAT traversal problem. And really, we solve the problem of running out of IPv4 addresses by just shoving a whole bunch of computers behind each one. And so if we want to talk to each other from computer to computer, well, even in this example I stole from the internet, it actually just says host and server. But let's say host and host. If they want to talk to each other, then we go out to the NAT, we create an outbound route, we connect to the other one. At that point, there's an inbound route, and it translates the IP into the internal IP. Great. Now that's fine if you have predefined routes. Of course, if you have short-lived peers or personal computers that want to talk to each other, you're going to need some way to configure the router to accept inbound connections. The most common approach is for consumer purposes is UPnP. It's mostly used for video games. So the piece of software tells the router, hey, I'd like a port. It says, okay, you got a port. Connections come in and it routes it. But that doesn't work, at a cafe or in places where you don't own the network. So there are the sort of terrifying but awesome workaround people use is a trick called UDP hole punching. I'm sort of skipping quickly over these things because I assume at a network company you already have a bunch of background on all this, but the idea behind UDP hole punching is basically that a UDP connection is transient and stateless, so the only way your router can know that there's a connection is by observing the packets that come and go. So the idea is that both clients go to a stun server, which is a third party, and basically ask what their IP address is. Then they swap those, and then I start writing packets to your IP based on what the stun server told me, with my router as the return address. And you start writing packets to my IP with your router as the return address. And then the routers observe those packets traveling out and go, well, I guess they want to talk to each other. And since UDP is stateless, there's not really any way of not doing that. So cool, great. That's how you do UDP NAT traversal. Now, there's only one small problem with that, which is that NAT traversal doesn't work in cafes, it doesn't work at libraries, it doesn't work in offices, and it doesn't work in most institutional settings where people collaborate in person. Why doesn't it work? It doesn't work because of this. It doesn't work because back in the 90s, people assumed that if you were plugged into a physical network, then you should have access to all these resources, right? Like physical network presence was access to networked assets. And so then people started getting laptops and taking them to cafes and libraries and other people's offices and getting all their data stolen off NFS shares. It also doesn't work because back in the day, a lot of people shared copyrighted content over BitTorrent and consumed huge amounts of bandwidth, which was both annoying and expensive for network administrators. So most public networks don't really permit local traffic or peer-to-peer connectivity. And the real catch is on some routers, but not on all routers, that UDP hole punching trick doesn't work if you have what's called a hairpin route, which is that you send a UDP packet to the router and the destination is actually yourself and come back in, please. And so that on some brands of routers and in some networks, you can do this. And that way, two people can communicate on the same network. And in others, you can't. And I have never for the life of me heard anyone explain why some brands or some routers do or don't, whether it's a security issue or just like somebody just made a setting and decided, oh, why would you want this? And just like drop those packets. I don't know the backstory here. But because of this hairpin NAT problem, we are left snookered. You can't do UPnP, you can't make direct connections because the Wi-Fi networks are not set up to allow them. And you can't even do this like NAT traversal trick. So, there's just literally no way to make an IP connection between two laptops sitting on the same table on the same Wi-Fi at the coffee shop a lot of the time. How often? There is anecdotal evidence that it's about 10 to 20% of peer-to-peer connections that route via turn servers don't successfully connect and then have to be carried by a relay server. It's hard. There's no real way that anyone can estimate what that really looks like. But I can say anecdotally in our research building peer-to-peer software, what would happen is we'd build a bunch of this stuff and it would work pretty well between all of us as researchers in different countries and cities. And then we'd go to meet somewhere at an Airbnb and nothing would work at all because the local Airbnb Wi-Fi just wouldn't support connectivity locally because it's just set up by default not to allow it because that's what you get out of the box. And so you're just totally out of luck without a relay server. So let's talk about the general form of the problem. The specific form of the problem is that if you ever find yourself in a position to solve this problem, simply changing the default to support hairpin NAT traversal of UDP packets would relieve a lot of the problems here and take us from something like, I don't know, 80% success rate to like 90 something plus success rate would be my total guess. So I think that would honestly be the biggest thing in the short term anyone could do. Very simple intervention. It'd take many years to roll out, but that's okay. Okay, so in the general case though, we have a problem. How do we get data? Well, we need to find the data, and then we need to get the data. We find it, we fetch it, right? So on the web, data is identified by an HTTP URL, right? So we all know what this looks like. We've got a server, and then we have a URL. And so the process of finding the data is we take this URL, which describes the universal resource locator, and we say, okay, I'm going to do a DNS lookup on the host name. So I find out the IP address of a computer that purports to serve these requests. Then I connect to it and I do a get, and I send it the string, and it sends me some data back. Pretty cool, very straightforward. We all know it pretty well. I'm going to contrast that with BitTorrent, which is a peer-to-peer system. We're going to look at a magnet URI. So a magnet URI is this form we see here, the XT-earn BTIH. And so what we see here is a little bit of like metadata at the front that describes how to parse the rest of it. And then the second half of this is, or the second half, the main portion of this is a hex string that is a key to look up in a distributed hash table. And so a client connects to a distributed hash table, which is a really cool trick for basically running an unreliable database across a whole bunch of computers. And so what you do is you can post data into this hash table, and then computers will hold on to data that they are given. And then our nodes will hold on to data that they're given. And then when a client connects to any node and says, hey, can I have this data? The node will look locally and say, okay, yeah, I have that, here you go. Or I don't have that, but I do know some other nodes who might have that. And so what they do is they take the data that you're requesting, and then they hash it against each of the possible peers that they know about. And whichever one has the lowest resulting numeric value is the one that you send the request to. And so what you get is consistent routing of requests where ideally this is sort of like a nice linearly progressing function, so that the closer you get to, as you do more hops, this number trends downward. And so it becomes more likely that when you're storing data, you forward data onto ones with lower counts. And when you're fetching data, you go to ones with lower counts. And so you have this nice kind of like stable routing system. It's a really cool trick. But of course, anybody could lie. So in order to make this work, what you do is when you get the data back from the network, you take the hash of the data, and that better be the key that you requested. And so that's a content addressed distributed hash table. Pretty cool trick. So we go out, we fetch that data, we bring it back, we make sure that it's what we requested. And then inside that data is something called a torrent file. And the torrent file lists some servers you can connect to, and those servers maintain a list of peers who promise to send you the data. And then you connect to those peers, and then you start fetching data from them directly, via NAT traversal and UPnP and UDP hole punching. And then, of course, because anyone can lie, it's the internet, nobody knows you're a dog. You also constantly check hashes. The torrent file has the Merkle tree root, so that you can always calculate the whether each block that you're receiving is actually the one that you're supposed to get for that static file. And that works pretty well, but it only works for static files. So with local first software, to find the data, we have a bunch of problems. One is that, I might be at the cafe today and at home tomorrow, and, logging in from, my, mobile hotspot another day. And so my IPs are always changing. So I can't use DNS to identify myself. And, the flip side is that this really cool distributed hash table, magnet, Merkle tree stuff that BitTorrent doesn't really work, because the data is malleable, but even more so, it's only held by a few users. BitTorrent works under the old Linus Torvalds, instead of using backups, just upload your data to the internet and let strangers mirror it for you. If your data is, copyrighted content, desirable copyrighted content, then many people will mirror it for you. But if your data is like notes from a meeting that you had with a colleague last week, then, strangers on the internet are not going to mirror it for you. So once we've found the data, we still need to figure out how we're going to fetch it. And as we've talked about, peer-to-peer connectivity doesn't work because of all these hole punching, NAT traversal, the hostile ISP problems, right? We've just kind of fallen into a metastable kind of configuration where, there's not much demand for peer-to-peer connectivity outside of certain niches because there's not much demand. And so the problems aren't fixed in terms of network availability. And so you have, I think for consumer software to work, you want to have like at least 4 nines of reliability in terms of like network connectivity. If I request data, I should be able to get it at least 99.9% of the time. And anecdotally, what we hear from WebRTC connections is that 10 or 20% of connections require stun servers. Now, why does this matter? Well, it matters because if we want software that's going to last, as we discussed sort of at the beginning of this talk, for decades, then we don't want every project to have to stand up its own servers and run them, because that's not going to last for decades, right? I can still pull a thumb drive off my shelf that's been sitting there for years and plug it into a new laptop and copy data off it. But if that data was hosted on an EC2 instance or in a Heroku app or otherwise on the internet, the odds are very low that it will still be there because there's this like constant incremental cost to hosting things online. So what to do? Well, the first is we could just have reliable UDP NAT traversal. No, okay. But really what we want is some kind of secure peer discovery mechanism to find collaborators or content. And then we need efficient and reliable asynchronous sharing of large corpuses. So like I can't be downloading, my whole, document archive every time any change is made. I want to be able to efficiently synchronize, from you and from other collaborators, just the bits of our work that are changing. I upload a new photo. I don't want to have to upload my whole photo stream every time. And then it's also important to have real-time collaboration. And so for hot data where we're working together, we need to be able to create very fast routes between clients. And as a general principle, I will also note that nobody is going to run any daemon that anybody writes. It's just not a thing. If you want to make software and you're trying to convince me that someone's going to install a daemon on their machine to participate in using that software, you've already lost. So, okay, somebody else's daemon is the solution. So we can either adopt shared infrastructure or else need no infrastructure. And I think because the peer-to-peer direct solution doesn't work, and also because you want your data to still be there when you close the lid of your laptop, then we're going to try and find some infrastructure. And we have experimented with a lot of different things over the years. We have tried IPFS and DAT and BitTorrent. We've tried Dropbox and Google Drive. That's a neat trick. Like you've already got a file store that someone else is paying for, and we'll stick the files in there. Hard to get the user interface right. We've explored using, plain Jane HTTP services like S3, or just sticking things on some arbitrary HTTP server like Apache. We've tried to build direct peer-to-peer things with MDNS and WebRTC. We've even tried doing like sort of party tricks, like we did WebRTC peer discovery over a Slack channel where all of the clients had bought keys and connected to the same chat channel, and then they'd chat with each other. And that worked pretty well until we had more than 5 people one day using the app, and we started hitting Slack chat flood control limitations where you couldn't send messages too quickly. It's like, okay, well, this was never a good idea, but now it's broken. And the other good trick somebody pointed out to me years ago that we've played with was that really email is the ultimate distributed persistent queue. You can send anyone an email anywhere in the world and they'll have that data forever, right? I can go back and look at my old Gmail. What if every app had an email account? So, none of these things are great solutions. And, kind of the like punchline to this whole talk is I don't really know what to do. We keep trying things and nothing's really panning out. And I would certainly welcome your experience as folks working in the space. Tailscale is a good one. I will come back to Tailscale later. But I want to kind of sum up some of this stuff. I believe that if we could build local first software, that it would feel better for users, that it would be substantially less expensive to build and run and operate, that it would respect users' data, and that it wouldn't be surveilling it, it wouldn't be uploading it. It's better for an enterprise context. You're not trusting random third-party startups with your valuable data. Everything can just live in your devices, whether they're network positioned or sort of like end user positioned. It would create all these new opportunities for new kinds of use cases. It would be easier to evolve them over time because you don't have these like single monoliths. And it could potentially last for decades because it doesn't rely on the constant care and feeding of these expensive, complicated, operations intensive cloud services. But it's hard to do today. And I think we could be better, faster, and cheaper if we can figure it out. Because I think that what we've done with software is, basically in the process of pursuing these like local incremental improvements, we've sort of tied a brick to the pencil, right? I contend that we can be better, faster, and cheaper because we're not like in some like local optimum where we've made trade-offs. We've just sort of slid away from the efficient frontier quite badly. And that if we just take the brick off the pencil, that we could all be building software that worked better and was easier to build and cost less and was just nicer to use. So the metaphor I like here is this is, the USS Nimitz. It's got a crew of 5,000. It's a US aircraft carrier. It cost $8.5 billion US. I assume those are not 2022 dollars. And I think that we're just kind of building software for everything in this kind of aircraft carrier pattern. And I'm not saying aircraft carriers haven't been strategically valuable to the US, but we only build aircraft carriers now. Every piece of software we build is an aircraft carrier now. And what we really need are bicycles a lot of the time, right? A bicycle has a crew of 1 and costs a heck of a lot less than $8.5 billion. I think that we have kind of lost our way in terms of software architecture and design because we're all sort of aping these hyperscale design models, which are insanely expensive and honestly kind of self-serving for cloud providers to promote, because how many millions of dollars on every successful startup now just go straight into the pockets of Amazon, every month. So a lot of the work that's going into this stuff is, it feels a little bit like we're on this like hostile planet. This is a shot of Mars looking back at I think it's Perseverance's rover tracks. And so, I often feel when I'm working on these things, like we have all of these unsolved problems, like the network is hostile, the operating system is hostile, the technologies don't exist, the community isn't there. But it just seems so promising in terms of what we could accomplish as a software development community if we can unlock these capabilities and rethink how we are designing software that, I also find it enormously exciting in the same way I feel when I look at these rovers inching their way across the Martian surface. And so I believe that we can, move from, this cloud era, right? If you go back through history, we had the mainframe era where software was this asset bundled in with $1 million computers, to a personal computing era where everybody had their own computer, but everything just existed in that machine. And I was teenage IT for a bunch of people and like dealt with all of the problems of that. And we've come into the cloud era, which had all of these great benefits, but now we're really starting to see where things are straining at the seams and falling apart. And I think that it's plausible that if we can solve some of these problems, that we could enter a new era of computing, which hybridizes the best elements of bygone years and enables just a new kind of generation of software and design and user capability. So that's what we're working on, and would love to hear how to solve some of these problems. And I hope that we'll find more people like yourselves who work on these problems over time as well. So that's all I've got for you today. I think I've come in just under time. I would love to answer questions. I'd love to hear your thoughts about how we can solve some of these problems. We have plenty of other writing. We have fought many of these problems extensively in terms of data migration and file formats and network infrastructure and everything else. And we've written a lot about those things. You can read them at incandswitch.com. We've published a ton of prototype code. You can read the local first essay, which recapitulates the first half of the talk in a lot more detail and has screenshots and links to other work and projects. And if you're interested in the CRDTs, there are plenty of example projects, and there's code up at GitHub in the AutoMerge org. And yeah, that's what I've got for you today.
Thank you, Peter. That was wonderful. And I don't know, looking at the chat, we've got sort of more comments than questions at this point, because you answered the early questions in the middle. If anyone, also a lot of people will have to drop off at 10 because they're sort of all on Zoom schedules and probably have the next
Yes.
thing coming up. But if anyone has questions and can stick around, I'm sure we could give it a few more minutes if anyone wants to speak up either in the chat or just unmute yourself or something.
I got one question by DM, which was, what about an open local API? And I want to actually specifically say, I think that's wrong. Sorry. So I think actually APIs are sort of the original sin of our computing era, because what they do is instead of exchanging data that you can understand and interpret later and make decisions about, if I download weather data in a CSV file from some service, an FTP service or something like that, or I go to NASA and I pull satellite data, then I've got it. I can decide what I do with it later. I can make a copy. I can choose how I work on it. But if I go to like a weather API and I query for one result, now I can't do anything with that unless I can go back to that API again, unless it's maintained, unless it's versioned, unless it's supported, unless I'm online, unless it's online. And we create these end-to-end couplings of all these different services. So I think maybe the most fundamental thing I hope you'll all take away from this is don't build APIs, synchronize data. And if we live in a world where instead of having APIs that require this constant maintenance of ever always available connections, instead what we should do is transfer data in well-documented formats that we can evolve over time and that people can store and update. And that's a lot of what the CRDT work is about. But you can also just send around CSV files. That's fine. JSON files are fine too. That's what the banking system really runs on.
Interesting. So you kept your most controversial comment for last.
Oh, I don't know. Is that the most controversial? Wow. Hard to predict these things.
I think Jordan had a question here in the chat.
Do I think that hyperscale providers will push back and talk about how local first won't work because this will disrupt their economics? I think that if we're right about the potential here, that basically there's an economic argument here, which is it will be cheaper to build better software for developers. And so it's as simple as that, which is that if I could build, a Slack competitor with a team of 10 and not have to build a 500-person DevOps team and put all my energy into the experience and the product instead of having to do all this extra work that does not add value to users, that I should be able over time, maybe Slack is a great product and it won't be outcompeted or there's other exogenous reasons, but I think it should be a competitive advantage to build this software in terms of lowering the cost of development to produce better results that are more easily adopted because they have favorable dynamics even in enterprise context from adoption and purchasing. If I was an enterprise purchaser, I would rather buy a thing where I know that I have the whole thing and I don't need the vendor to continue to operate to maintain my current level of service even. So you can go to business and I still have the product. Same as if I bought, desks from a vendor or, a security system. Yeah, it'd be great if you can come back and do maintenance, but I can hire someone else if you close up shop.
Cool. So let's see if anyone else has something to add. Right now, I don't see more questions. I see, oh, there's one.
Just missed it.
You see it?
Chat. Storage requirements increase significantly rather than a single copy source of truth as many copies of the data. No. I mean, for individuals, the storage requirements remain pretty similar. The storage is highly distributed. I guess what I would say is that if you have never complained about the size of checking out your Git repos or, having, Google Docs on your system, then you probably will be fine. Anecdotally, right, you can store all of the data. I heard this at an Internet Archive talk, so this is my relatively unsourced data, but the speaker claimed that all of the data you will encounter in an entire year, except for streaming video and audio, can be stored on a single SD card that you could buy for less than $20 and fits in the size of your pinky fingernail. So I think storage costs are the lowest scale problem. I think actually bandwidth is a bigger problem. So figuring out how to prioritize what data to synchronize in what order and making sure we have efficient protocols for synchronization so we're not sending umpteen copies of the same things around, and like in mobile devices where you have limited bandwidth, making sure that you get just what you need, or where you have limited storage and you can decide what to keep. Those are all interesting problems, but I don't think that they are intractable. And if we just argue from a position like we can keep things the same, but just don't throw the data out once you download it, that would get us pretty far. Something like a Word document being edited on a local machine, shared on SharePoint for others to edit, maintain the local copy by downloading the latest from the SharePoint. Yeah, kind of like this, but the idea we have is that, what the CRDT gives us, and this is why we've invested in it, and we think it's important, is the ability to just work at a delta level on arbitrary documents, just like you do with Git. But Git only works really and barely works at all on source code because it's plain text, whereas modern CRDTs can operate on arbitrary shaped data structures, like basically equivalent to JSON, where you can have nests of maps and lists, and so you can cover a lot with that. All right, well, thank you so much for having me. It's been a pleasure to speak with you. I hope you'll think about these problems in your work and how you can help enable these things. There will always be more bandwidth, but there will always be new places where we go that we don't have bandwidth. And as we all know, the higher the bandwidth is, the harder time it has getting through walls and so on. So I don't think we will ever really escape problems of bandwidth and network access. And if you believe that we have, I now curse you to notice every time your network connection doesn't work. So yeah, with that, I guess I'll let you all go, and see you next time.
Thank you so much.